Hey guys, and welcome back to another video. In this video I'm going to be solving the Google Hashcode pizza problem. So let's get right into it. I'm going to start off by explaining the problem. So basically we have a specific amount of slices of pizza that we need, right? So in this case it's 17 slices, and we have 4 different types of pizzas. So we're going to have like 5 input files. This is just one example, and some of them are going to be like really big, so we'll have like maybe 1,000 types of pizzas or something, I don't know. But we need 17 slices, and we have 4 types of pizzas, and each type we have the amount of slices in each type. So the first type is 8, and then 6, 5, 2. So basically we want to create an algorithm that efficiently chooses which pizzas to take to get to the nearest number to these slices that we require. So and we don't want to go over that, we just want to be closest to it but under it or equal to it. So basically in this example, so we need 17, and we can go, for example, 8 plus 6, that's 14, plus 5, that's 19. We can't do that. So 8 plus 6, 14 plus 2, that's 16, and that would be the best solution for this one, because we can't get to 17, and like there's no way to add these up and get to 17. So the best solution would be 16, so we'll choose 8, 6, and 2. So basically let's get right into it. So the algorithm I created actually gets us the best scores possible for this problem. So so I'm gonna start off by basically arranging the types of pizzas based on how big the amount of slices each pizza has. So in this case it's already arranged for us, but some of them are not going to be arranged like that, so we're going to have to do that ourselves. And so in this case it's going to be 8, 6, 5, 2. That's how it's going to be. And we'll start off from 8, and then we'll add on 6, and then we'll add on 5. And in this case it's not going to be good. Well, actually it will be good, because we're going to say 8 plus 6, which is 14, and then we're going to add on 5, but see, it's 19, which is bigger than 17, so we're not going to take that and go on to the next one, which is 2, and then it will give us 16. So the algorithm would work in this case, and it would work for I think 4 cases, but just one of them doesn't work. Like, it works, but it gives us a high score as well, but just not the perfect score. So we're going to add on to this algorithm later, but just for starters I'm going to be arranging them from biggest to lowest to smallest, and then we're just going to add them up one by one, basically. And let me just show you that the score is actually 16 points for this one, for this example. So that's the best score you can get, 16 points for this example. So let's get right into it. So you can download this from the GitHub repository I have. The link is in the description, and the algorithm is actually done over there, but you could just download it and delete the algorithm. So okay, so I'm gonna start off by arranging the pizzas from biggest to smallest, and I was wrong when I said that they aren't actually arranged. So if you go to the input folder, and so I already showed you this example, but there's also this example and others. It's actually arranged from smallest, so 4, 14, it starts from the smallest and goes to the biggest. And so I'm just going to reverse the array, and then that should be from biggest to smallest instead of from smallest to biggest. So so I'll say let pizzas, I'll make a new variable called pizzas, and it will be equal to the inputs. So we are receiving it as inputs over here, and so those are the pizzas, and then we'll just reverse them, and then that should set it from biggest to smallest. So before I actually go further into this algorithm, let me just explain these arguments that we have over here. So let me open up a file, one of the input files, put them here. So so the max is basically the maximum slices that we need. So 17, that's the max. The pizzas amount is the amount of types of pizzas that we have, so 4. And then the inputs is an array of the pizzas over here. And then the file name is just the name of the input file. So over here is a example, B small, C medium, and so on. So so I hope this makes sense, and now we can go on. So okay. So the maximum amount of slices, for some reason I get an error when I don't do this, so sometimes I get this error. So I'm just gonna say pass int max. It's kind of weird, but I don't know why. So so let's do that. And also I'm going to have an array of answers, and then I'll pick the best answer from there. So let's just make a new variable and do that. And also I'm gonna have a boolean to check if we have solved it yet or no. So I'm just gonna set it to false for starters. because if we have solved it, then there's no point carrying on with the for loop and just keep trying out other possibilities. So we'll just break if we've already solved it. So yeah, we should be good now. We can start. So just make a for loop. Let I is equal to 0, and we're going to loop over all the pizzas. So I is smaller than pizzas.length, or pizzas amount, doesn't really make a difference because they're going to be equal. Pizzas.length, let's just say pizzas amount shorter, and then I++. Okay, and then we're going to have a variable called answer, set it to 0. So the answer we're going to have when we start off with this pizza with the index I. So yeah, okay, and then we're going to have another for loop inside this for loop, and we'll say for let j is equal to I. Actually, we're going to start off from I and go on all the pizzas from there. So basically we're going to start off from the first one, which is going to be 8, and then plus 6 plus 5, well, plus 5 is not going to work, it's going to be 19, so we'll skip that and then go on to the next one, which is 2. And then after we do that, so in this case it's going to be perfect for us, but in other cases it might not be. So after we start off from 8, we're going to leave 8 and start off from 6, and then we'll say 6 plus 5, 11, plus 2 is 13, which is still a possibility. In this case it's not the right answer, it's not the perfect answer, it still is an answer, but yeah, it is a possibility. So in B small, for example, if we start off with 95, then so 95 plus 95 is not going to be 100, so we skip that. Skip these until we get to 4, which gives us 99. But that is not the perfect answer, so we want to start off from the next one, yeah, which is also 95, so it doesn't really make a difference. But then if we start off from 82, we can't add 36, can't add 32, can't add 29, but we can add 18, which gives us 100, so that gives us a perfect score, and that is better than 95 plus 4, which is 99. So yeah, so we'll just so we're going to have a for loop that starts off from this one, and then starts off from this one, starts off from this one, and so on. So yeah, so let's have another for loop inside this. So we're going to start off from I, and then we're going to say j is smaller than pizza's amount as well, and then j++, and then we're going to find that pizza. So let pizza is equal to pizzas at j, and for some reason I also need to pass it into this, so just do that. Okay, and then we would like to check if the answer plus this pizza is bigger than or equal to the maximum amount of slices. Sorry, smaller than, not bigger than, because if it's bigger than, then we don't want to add it up. So yeah, if it's smaller than or equal to, then we'll say answer plus equals pizza. So we just add on the pizza to the answer. And remember, I never mentioned this, but we can only use the pizza once. So yeah, and then if the answer is equal to max, then we'll set solved to true, and we'll just break. And we're going to need this solved variable later on for another for loop. And also remember, I had an answers array to store my answers, so I'm just going to push in, not really push in, I'm just going to set answers to this answer. So that means we just found our answer. There's no point having all the other answers because this is a perfect score, because it just equals the answer equals to maximum slices, so it's a perfect score, no need to check the other answers. So yeah, and if it isn't, then we don't really want to do anything, and we just skip that pizza. But that's what we're going to do for now. Later on we're going to add on to this algorithm, and we won't be skipping that pizza, we'll be doing some more stuff. So yeah, so after this for loop we want to push in our answer, because right now we are only putting it in answers if it's a perfect score. We want to also push it if it's not a perfect score, because some of them might not have the perfect score, like it's equal to the maximum exactly. So yeah, so we'll push it after this for loop, and then we will check if solved. So if it's true, then we'll also break. There's no point carrying on with this for loop. So yeah, so we did it over here, but that just takes us out of this for loop and not out of this for loop. So we just want to take us out of this for loop as well, because as you can see in E also big, look at how many we have. I think 10,000 types of pizzas. So we don't want to carry on with those if we already found our solution. So yeah, so now let's run this. I think this should be like a perfect score for most of them. So node solution slash solution.js. Oh, we need to console.log our answer. Okay, so console.log, we'll say the file name, plus we'll have a string, we'll say max score colon, and then we'll put in our we'll get the biggest number in the answers. So we'll say math.max, so give us the biggest value, and we'll just get a copy of the answers. Save that, and now let's run it. And there you go. So 16 and 100 and 4,500, and this number I think is 505 million, I believe. That is the best score for those, but just for this one, the best score isn't actually this. It's a bit bigger than this, like a tiny bit bigger. So this would actually be a really good score right now. But we want to get a perfect score. So it's just this file left. So D quite big. And yeah. So we're going to have to add on a lot to this algorithm just to get this as a final as a perfect score. So this part is going to be quite tricky to explain, but I'm going to try my best. So basically what I'm going to do is if answer plus pizza is not smaller than or equal to, so if it's bigger than maximum amount of slices, then what I'm going to do is I'm going to minus the answer from the former pizza that we used, which was a quite big pizza compared to this pizza. Well, it was definitely bigger than this pizza, because remember we arranged it by biggest to smallest. So yeah, so we're going to minus that and then add on this pizza, and then we're going to save the index of this pizza, and we're going to carry on from there in a different for loop. So it's quite tricky to understand and explain, so I'll just try my best to implement this and explain it as I go. So I'm going to have a variable called stopping points. So it's going to be an array of stopping points, which we are going to get back to and start from there again. So yeah, so it's just going to be an empty array, and I'm going to actually have a variable called pizza index, and I'm going to set it to null for starters. And then yeah, so if the answer plus pizza is smaller than or equal to max, then I will say the pizza index is equal to j, so the index of this pizza. And the reason I'm doing that is because this is going to be the last pizza that we have actually added on to the answer. So if when we use the else over here, so if we say else, then for right now this is the last pizza, the index of the last pizza that we actually added on to answer. So we want to remove that from the answer. So we're saving the index of it so we can remove it now. We're not going to remove it from the answer, but we're going to have a variable and remove it from the answer and store it in that variable. But we're not going to actually remove it from the answer, because we're going to carry on with this for loop, and we're going to have another for loop after this. So I hope that makes sense. And we're going to say stopping points dot push, and we're going to have an object here. So we're going to have answer, an answer property, and that's just going to be the answer minus pizzas, and then at pizza index, so the index we are storing. So the last pizza we added to the answer, we're going to minus it from there, and we'll add on this pizza. We'll add on the pizza over here. So we'll add on this pizza because we can't add it on because it's not smaller than or equal to, but maybe when we minus the former pizza, which is bigger than it, so definitely, then we can add on this pizza, because the last pizza was bigger than this pizza. Then we can definitely add on this pizza if we minus that one, and that will give us much more possibilities. So yeah, and then we want to save the index in another property. So we'll just say start from, because we're going to have another for loop that goes through the pizzas again from this index. So we're going to start from j plus 1, because we already added the j over here. So we said plus pizza. So the pizza at index j has already been added, and we don't want to add it again because we can only use the pizza once. So we're going to say j plus 1, and we'll start off from this index, j plus 1. So yeah, and now after this for loop, or this for loop actually, we will check if we haven't solved, because there's no point doing this if we have actually solved it. So if it's like we got the perfect score. So if we haven't solved it yet, then we'll do this other for loop. So we'll say for let k is equal to 0 and k is smaller than the stopping points. So we're going to be looping over the stopping points. K plus plus, or stopping points dot length, sorry. Dot length. And then just like we did here, so we're going to map over the pizzas. So we'll have another for loop, and then we'll say L is equal to K. We'll set it to K because we want to start off from this index. And then L is smaller than the pizzas amount because we're going to be looping over the pizzas. And we'll say L plus plus. Sorry, L is not going to be equal to K. It's going to be equal to stopping points dot start from. Stopping points at K, sorry. So yeah, so we're going to be looping over the stopping points and then start from property of each stopping point because that's what we want to do, and then carry on from there. So yeah, and then we're going to have a variable called answer to keep track of our answer, and we'll say stopping points at k dot answer. So we want to use our former answer and go on from there. So this is going to be our starting answer basically, and this isn't cheating because we're not going to be using the old pizzas that we already used. We're going to be going from the pizza that we left off from. All we did was just skip a big pizza and that's it. So that's not cheating because we don't have to use all the pizzas. So yeah, we'll get that answer and add it to the pizzas at L. So the L is equal to the starting point, so dot start from the starting index, and then we'll start from there, and then we're just going to add it by 1 each time, which is not cheating because we haven't used those pizzas yet. So yeah, okay. And now we want to check if the answer is equal to max again. Is equal to max. Sorry, smaller than or equal to max, not just equal, because we don't want it to. It's not always going to be actually equal to max. So if it is, then we'll say answer plus equals max, and then we'll check if it's solved again. So we just break, and there's no point carrying on. If solved, then sorry, if answer is equal to max, then we'll set it to solved. We'll set solved to true, and then we'll say solved is equal to true, and we'll break out of this for loop. And also, just like before, we'll set the answers to the current answer right now, because that means we have found our perfect score, and there's no point checking all the other answers because this is the exact answer we want. And yeah, and then after we've done this with this for loop, then we'll also check if solved, and we'll just break out of this as well because there's no need to carry on. So yeah, so this number is actually going to be bigger, but the rest are going to be the same because that's the perfect score for the other ones. And let's go ahead. So it's not working actually. Why is that? So if answer plus equals max. Oh, we're not actually pushing the answer into answers, and that's what we're meant to do. So answers dot push answer, and then save it. We're only actually pushing it to answers if it's it's actually equal to max, which not all of them are going to be equal to max, even though it's not. Like, it could be a perfect score and it's not equal to maximum amount of slices. It could be less than it, but it will be a perfect score. Like, you can't get a better score. So, and that is the case for this one. And we're still not getting the correct, like the perfect score. It's still a good score, but it's not a perfect score. Let's go over this again. That answer is equal to that. We need to say %. This is one of the weird errors that I was getting. Save that, and I think we should be good now. Yeah, there we go. So clearly this is an issue because we're meant to actually get this and not this. This is too far. So the maximum we want is actually that. So actually, yeah, it is a perfect score. But yeah. So this is the issue. We are plussing it by max. So we're getting the max and we're plussing it by max. So that's double the max. And we don't want to do that because we're actually getting the answer over here, so we don't have to plus it, add something to it again, we'll just push it. If it is smaller than or equal to max, then we'll just push it as an answer. There's no point. So let's redo this, and there we go. Perfect, it's working. So this is the perfect score. This is the best score you can get on Google Hashcode pizza problem. So I hope you understand this algorithm. It's not that complicated, but it's kind of hard to explain. So yeah, thanks again for watching this video. Please like and subscribe, and goodbye.